Hey everyone, welcome back to another Firecast about cloud functions for Firebase. My name is Doug Stevenson, and today's topic is advanced programming with JavaScript promises in cloud functions for Firebase. In the last two videos of this series, I talked about using promises to manage the work happening in an HTTP trigger and a Firestore trigger. Each type of trigger had a slightly different way of working with the promises returned by the Firestore API and the Firebase admin SDK. In particular, you learned the basics of JavaScript promises and how to use them. And you also saw two rules for terminating a cloud function, which are these. First, HTTP triggers must send a response to the client to terminate properly. And second, for all other types of triggers, called background triggers, you must return a promise that becomes fulfilled or rejected when all the pending work in that function is complete. This lets cloud functions know when it's safe to clean up the function invocation and move on to the next one. The code I've showed you so far is fairly simple. Let's go over again what it looks like. My Firestore database contains a collection called Cities Weather, which contains documents for a few different cities. Each document stays up to date with the current weather conditions at that city. This HTTP trigger I have right now fetches and returns the current weather conditions in Boston. You can see it makes a request to Firestore to get the document at the known location. The get method returns a promise that's fulfilled with a snapshot of the document, which I can then convert to a JavaScript object and then send back to the client in JSON format. And if the promise is rejected with an error, I handle that too. Now, what I want to do here is group neighboring cities by a larger area and create an HTTP trigger that returns the weather conditions for all the cities in that area. So what I've done is created another collection in Firestore called Areas, and the documents in there contain a list of cities in that area. Let's take a look. Now, in Firestore, you can see that new collection, and it contains a document for the greater Boston area. This document has a property called Cities, which is an array of city IDs in that area. Right now, it's just Boston, Cambridge, and Somerville. This is an incomplete list, and I'll update that later. So what I need to do is create a new HTTP trigger that reads the Boston area document, gets this list of cities, reads each of the matching documents from the city's weather collection, and returns them to the client. So I'll switch to VS Code and start writing that. What I'll do here is export a new HTTP function called getBostonAreaWeather. In that function, I'm going to query that Boston area document. Get returns a promise, so I'll use the then method on that to get the document snapshot when the query is complete. I'll convert that snapshot to a JavaScript object, then access the document property called Cities that has the array of city IDs. I can iterate this array, then build a reference to each city's weather document that I need to read. There's a little snag here. Each of these calls to get returns a promise, and there will be several for each area. And I need to wait on all of them to finish and get all of their data to send to the client. Now in this situation, I don't necessarily know how many cities there will be, but I need all their results. And I don't need to wait for each one to complete one after another. They can happen all at the same time in parallel. So what I really want to do here is kick off all the queries at the same time, then continue after all of them are complete. Once I have the entire set of documents, I'll send a final response to the client. And I can manage this all with a function called promise.all. Let's see how that works. First, I'll collect all the promises into an array. I can do that by creating an empty array before the loop. Then inside the loop, I'll push each promise into that array. Remember that get returns immediately, so each one of these promises is still in the pending state and should be fulfilled later on. Once I have the promises collected, my code needs to wait for all of these promises to become fulfilled before moving on. I can use the function promise.all, pass it the array of promises, and it will return a new promise that's fulfilled only after all of those other promises are fulfilled. With that, I can call its then method to continue with more work, but that means I'm nesting my code deeper than necessary. The best thing to do here is to return that promise from the callback. Now let's see what happens to a promise return like this. If you return a promise from a then callback, the then method itself returns a new promise that becomes fulfilled or rejected at the same time as that other returned promise. With that new promise, you can chain another then method to it to continue where that work left off. You can use this to write another callback that receives the results from the promise fulfilled in the prior callback. In this case, it's an array of document snapshots with the result from each get. So This snapshots argument is the array of the document snapshots that are fulfilled from the array of promises above. What I'll do here is iterate that array of snapshots to collect all the weather condition objects for each city. But what should I do with all these objects? Well, I'll create a new array with all the results and push them there. Then I can send that array of results to the client in JSON format. Oh, and while I'm here, I'll do the right thing and paste a call to catch after this so I can deal with any errors that occur. Remember, it's critical to return a response in all circumstances. Okay, let's see what that JSON looks like. At my command shell, in my project functions folder, what I'll do now is run the linter, and after that's okay, compile the TypeScript to JavaScript. Then I'll run the emulator for HTTP functions. It gives me a localhost URL for the get Boston area weather function. So I'll copy it, switch to another shell tab, and run this curl command to see what it returned. Cool. And I can see all the Boston area weather documents here. This is a good start, but I can't tell which city each object refers to. So I'll go back into VS Code, change the callback to add the unique document ID to each JavaScript object, then push that modified object into the results array. Then I'll go back to my shell, compile the TypeScript, run the emulator, and then use curl again to view the results. And there we go. This is kind of hard to read though, so I'll pipe it to a Python pretty printer just to make that easier. Nice. Doesn't that look a lot better for testing and debugging? I think so. So we saw two new techniques here for dealing with promises. First, you can chain together items of work by returning a promise from the callback of the then method. Just like returning a promise to Cloud Functions, this promise must represent all the async work that was started here. When the promise returned by the callback is fulfilled, the next promise callback will receive the results generated by the prior one. And the catch callback will capture errors from any of the prior work. The final promise returned from catch will be fulfilled or rejected after the entire sequence is complete. The second thing you learned is that you can kick off many different items of work asynchronously, collect all their promises into an array, and use promise.all to create a new promise that's fulfilled when all the other promises are also fulfilled. That new promise delivers an array of results to the next callback. You should also know that if any of those promises becomes rejected with an error, the promise returned from promise.all will also become rejected. And that's it. Once you get practice with these techniques, it becomes easier to write more complicated code for Cloud Functions while you're following the two rules to terminate your functions correctly. Now, for functions written in TypeScript, which I am using here, there's an even easier way to deal with series of promises. TypeScript gives you a syntax called async await that makes dealing with promises super easy. So, if you want to see how that works, subscribe right here to the Firebase channel on YouTube to get notified of the next video in this series. And I'll see you here next time.